the last video, we've demonstrated how solver from Z3 can help us solve CTF challenges. Today, we will see some cases when a naive solver might not be enough. As a recap from last video, we use Z3 adding rules between characters that needs to be all fulfilled to get the correct input. Once we are done with that, we can check with the solver if it can provide such value. Now imagine a different scenario. This time we want to use Z3 not just to solve a set of equations, but to optimize the result, that is to maximize or minimize a value while satisfying constraints. A regular solver can find a valid solution, but it won't necessarily be the best one, and might even take longer in some cases. To see this in action, we can check PlaidCTF 2025 task Prospecting. It was a two-part challenge where we could use Z3 to help us solve them, but without certain trick, we would be waiting too long for them to get the flag in time. Let's start by checking the first binary in Ghidra. The main method contains the whole challenge. First, there's some printing done and we read the input. Next, certain conditions are being checked, and in case the condition is true, a bump method is called, bumping the score variable by 1. At the end of the method, we have a group of checks that verifies how big the score is. If we go over a certain threshold, a specific message is outputted, and if we manage to get over 281, we know we get the flag. We might think we can use already known solver class so that we will get all the rules passing, but we can quickly see that they cannot be all true at the same time. Let's take for example those two rules. They cannot be both true at the same time. Either 12 character is equal to one value or the other. So our solution needs to pick such combination of flag values so that we get the max out of the algorithm. And picking one value here will influence other conditions and how many points we will get from them. And if we remember from the code, it has to give us at least 281. Let's see how we can solve that using Z3. The code starts in a similar fashion to the one from the previous video. We import everything from Z3 and we create an array of bitvec variables to store our input. From the challenge code, we know that it should have 64 characters. Next, we create a list of conditions extracted from the binary. We do not add them directly to any solver, as we know not all of them should be true at the same time. To get the correct value, we need to make only some of them true conditionally. For that, we can use the if function from Z3. It takes three values. First is an expression that we want to evaluate. Second is the value that will be used when the expression is true, and the third one is when the expression is false. In our case, we will use 1 and 0 here respectively. This will simulate calling the bump method from the binary when the expression is true. And we want Z3 to optimize the sum that we can get from all those expressions. For that, we call maximize function from the optimize object. And that's the key to be able to find the solution in time. And that's it. We call the check method, and if it returns SAT, we can get a solution from the model. Running the script will give us the flag. In the next challenge, we will see how we can get more out of Z3 even in the case when optimize doesn't give us any results in a limited time.